Chapter 6, Section 1 is about two-dimensional vectors. Let's begin by graphing something we're familiar with. Point 27. We would start at the origin, move right 2, up 7, and this point is coordinate 2, 7. Graphing the coordinate 2, 7 is unique. In other words, there is only one way to plot the point 2, 7. Let's look at vector 2, 7. First of all, the notation used here for vector 2, 7 is called component form. The graph of a vector is not unique. But let's begin by graphing vector 2, 7 in standard form. Graphing a vector in standard form has 3 steps. You begin by plotting a point at the origin, putting an arrow where the coordinate 2, 7 would be, and connecting the origin to the arrow. This is a graph of vector 2, 7 in standard form. Now for some vocabulary. The 2 and the 7 are known as components. The whole thing is the vector written in component form. The point where the vector starts is known as the tail. The arrow is known as the head of the vector. The length of the segment that connects the tail to the head is the magnitude. The arrow is what gives the vector direction. Vectors are used to represent force, velocity, acceleration. They all have a magnitude and a direction. Okay, so let's say we are asked to graph vector v. To graph the vector in standard form, we would plot a point at the origin. This would be the tail. Then we would draw an arrow at the coordinate 2, 7. Connecting the tail to the head, we would have drawn vector v in standard form. If we label the tail B and label the head U, in arrow form, we could name vector v vector BU. Graphs of vectors are not unique. Here is another graph of vector v, vector PK. These are both graphs of vector v because they have the same magnitude and the same direction. Here are 2 more graphs of vector v. Vector MA and vector GN are both graphs of vector v. You can start the graph of vector v at any point you like. Let's say we decide to place the tail at this red dot. From this point, we would go right 2, up 7, and draw an arrow, and then connect the point, which is the tail, to the head, which is the arrow. If we label the tail R and the head D, when we write the vector, we must start with the letter that labels the tail and go to the head. Vector RD is not the same as vector DR. There are 3 different ways to write a vector: component form, arrow form, and linear combination form. Let's graph each of these 3 vectors. Beginning with vector 3, 4, written in component form, if we wanted to graph this vector in standard form, we would begin by plotting a point at the origin. From this point, moving right 3, down 4, and drawing an arrow. Connecting, we have now graphed the vector 3, -4 in standard form. The graph of a vector is not unique. I could begin the vector at any point I want. Let's say I begin the vector here. From this point, move right 3, down 4, draw an arrow, and connect. Here is another graph of vector 3, -4. This is yet another example of the graph of vector 3, -4. As long as the magnitude and the direction of the vector is the same, they are the same vector. Moving on to graphing vector PQ, which is in arrow form. We would start by graphing the tail P at the coordinate -2, 7, and then we would graph the head Q at point 1, 3. Connecting. Because P comes before Q, P must be the point and Q must be the arrow. Now let's graph vector -3i minus 4j, which is in linear combination form. If we graphed this vector in standard form, we would begin by putting our first point at the origin. The number in front of I tells us how much to move right or left. The number in front of j tells us how much to move up or down. From this point, we will go left 3 and down 4, drawing an arrow in that location. Connecting. And now we have a graph of vector -3i minus 4j. Again, the graph of a vector is not unique. We could start vector -3i minus 4j from any location. Let's say we started here. From this point, we would move left 3, down 4, and draw an arrow and connect. Here is another graph, although not in standard form, of vector -3i minus 4j. Here is another graph of vector -3i minus 4j. Here we are starting with the graph of a vector. We want to write the name of the vector using all three notations. Let's start with component form. We want to start at the tail A. To get to the head B, we would need to move left 3, then down 2. The vector in the picture in component form is vector -3, -2. Using arrow form, the vector begins at A and finishes at B. In arrow form, we have vector AB. Using linear combination form, to move from A to B, we would move left 3, so the number in front of I is -3, and we would move down 2, so the number in front of j is -2. The vector written in linear combination form is -3i minus 2j.